Algebra, Unit 10, Lesson 9, Solving Quadratic Word Problems, Notes, and Video 9. All right, very important with our directions here. So we've learned how to do many different kinds of quadratic problems and solving them. So the good news for this is answer the following questions by any method you choose. Now, that's by any algebraic mathematical operation you choose. You're not doing any of these in your head. Lots of work should be shown. Be sure to define a variable. So the good news with this is we've done problems like this, word problems like this, ELA word problems where we had to translate them to math or translate them to algebra for the whole year. Way back in units 1, 2, and 3, we did many problems like this. So a lot of this is going to be good review. The only difference is these are quadratic. So we're going to have squares and square rooting and using factoring, GCF, difference of two squares, a trinomial where a is 1 or a is greater than 1. We could have factor by grouping. We could have the quadratic formula. We could have completing the square. So all of these things are going to be relevant here. Letter A. The square of a positive number decreased by 4 times the number is equal to 21. Find the number. So I'm going to start with let x equal, let's see, the square of a positive number. So let x equal a positive number. Now I'm going to translate this to math. So the square of a positive number. So x squared decreased by 4 times that number is 21. So here is my equation. So in order for me to solve this, I need to start by putting it in standard form. So x squared minus 4x minus 21 equals 0. And now any way I know. So I'm going to start way back at the beginning with my, what am I doing here? Is there a GCF? No. Is it a difference of two squares? No. Can I factor by, is it a trinomial where I can factor where a is 1? The question is, I don't know. So I can try by doing that. Might be your favorite one. So I'm going to think, okay, double bubble equals 0. Now, unless you take some time or you're really good at this, you really can't do this in your head. Now, with time, yes, of course, you'll be able to. So right now, it's kind of guessing. Do you do GCF? Is it a difference of two squares? Like, you're using mathematical ideas, but you don't really know the answer. So just remember, the quadratic formula always works. It's the longest and the most lengthy process, but it always works. So feel free to always do that. You don't have to do what I'm doing, but I want you to do, again, sometimes the more you look at a problem, the quicker you get, and then you'll have doors open. So for this one, I'm going to try to double bubble. Again, you do not have to. So I need two things that multiply to 21 that add to 4. Now both of those are negative. So again, if you need to, write your list. Multiply to 21, where something here, the factors, are going to add to negative 4. Again, a lot of you can do this in your head, so please do. So how do I get x squared? I get x times x. 21, let's see, is 7 and 3. If I apply those, I get 21. If I add them, I'll get 4 if 7 is negative and 3 is positive. So I have two things that when multiplied equals 0. So that means I can kind of split this up. I can say that x minus 7 is 0, or x plus 3 is 0. So if I solve both of these, drop the wall, which again I'm hoping you can skip some step here and not show too much work, we get x equals 7, or x equals negative 3. Okay, now let's go back. We need the square of a positive number. X is a positive number, so x equals 7. It cannot equal negative 3 because it's negative. So find the number. The number is 7. We're done. Letter B. The product of two consecutive positive even integers is 80. Find the integer. So again, this one goes way, way back again to the beginning of the year. Let x equal a number. So the product of two consecutive positive even integers. So let x, they have to be consecutive, so you have to go in order, but they have to be even. So think like 2 and 4. So way back from the beginning of the year then, how do you get from 2 to 4? You add 2, so let x plus 2 equal the second number. So then my equation is the product of those two things. So x times x plus 2 is 80. Here is a distribution problem. X squared plus 2x equals 80. I need this in standard form. X squared plus 2x minus 80 equals 0. All right, from there, again, is it a GCF? No. Difference between squares? No. Is it a trinomial where a is 1? Yes. So again, I could try to double bubble. Again, you're going through these steps in your head each time. So I need two things that multiply to 80 that add to 2. I got them. I hope you do. So we have x and x. So think about it. Two things that multiply to 80 add to 2. Need a positive 10 and a negative 8. Multiply negative 80, check. Add to 2, check. So we get x equals negative 10. X equals 8. Again, skipping a step. Hope you're comfortable with that. If you're not, that's fine. The product of these two things equals 0, so one of them or both must equal 0. So you're splitting it up into two problems. And at the problem, positive even integers. So this is not even, so the answer must be x is 8. Now it says find the integers, so the first number is 8, and the second number, x plus 2, is 10. I'm going to go ahead and let you try C and D on your own. Good luck. I also want you to try these 4 on your own. They're definitely all ones that you can handle. For H, 3 consecutive odd integers, you need 3 let statements. And yep, you can definitely do those on your own. Good luck. Alright, let's look at letter J together. A toy rocket is launched from the ground, not from the ground, straight upward. So if you picture that, it should be looking like a parabola, and it should look like a parabola upside down, so opening downward or that frowny face. The height above the rocket, the height of the rocket above the ground in feet is represented by the equation. So h of t is the height at time t. Negative 16t squared plus 64t, where t is time in seconds. Determine the domain for this function in the given context. Explain your reasoning. Okay, so lots of good stuff here. Explain, we need words in terms of the context, so we're talking about a rocket. So I'm going to visualize here. We're going to shoot the rocket off. It's going to have a turning point or maximum point. The gravity's going to start to take hold, and it's going to end up on the ground. Now this part down here is the ground. So these are my x values. My domain are the x values. So I'm looking for time here, and that will give me my domain. In order for us to find the domain, then, we need where this parabola equals 0 on the x-axis, or what are the roots? So that's visually how we get through the game, or this word problem. So where we need to find where x is 0 is the roots. So our equation then is negative 16t squared plus 64t equals 0. So again, I'm going to start and go through all my options for factoring quadratics. 1. Is there a greatest common factor? Yes. So we're going to pull that out, and it's negative 16t. So we're left with t minus 4 equals 0. So now we have the product of two factors that equal 0, which means one of those factors or both must be 0, independent upon the other. So negative 16t could equal 0, or t minus 4 could equal 0. So I'm going to solve both of those, and I get t equals 4, or t equals 0. So my domain is x such that 0 is less than or equal to x, which is less than or equal to 4. Now the problem with that is it says determine the domain of this function in the given context, explain your answer. So this answer is kind of irrelevant, but it gives us practice in writing it down. So the domain is our x values. So So the domain is represented when the rocket is in motion. The rocket leaves the ground at 0 seconds and lands back on the ground 4 seconds later. So the domain speaks about from the time 0 to 4. All right. I would like you to do the next two here on your own. All right, letter M is a Great Regents exam problem. A rectangular garden measures 12 meters by 16 meters. So we can see that picture in the rectangle in the middle, labeled garden with 16 by 12 given to you. It's going to have a walkway installed around it. So a walkway goes around the outside, all the way around the outside, with a width of X meters as shown in the diagram. So notice the width of this sidewalk is X on every side. Together, the walkway and the garden have an area of 396 square meters. Write an equation that can be used to find X, the width of the walkway. All right. So the entire area, together the walkway and the garden have an area of 396. So this whole piece is 396. So first we need to start by saying, okay, well, what is the length and the width of this shape? So we need to find this and this, because in order to find the area of a two-dimensional thing, we need, and a rectangle in this case, we do length times width. So we need to know what those two are. So I'm looking for this dimension here. So it sounds like I already know that this is 12. So I need to add on what is this and what is this. Well, that's X and X. So let's say the length in this case. So area is length times width, or base times height, either one. So area equals, so the base then, or one of the two dimensions we just said was 12 plus X plus X. Well, let's make that 2X plus 12, so we're putting it in standard form. Let's switch colors here now. We need this dimension here, which is something, but we know that this piece is 16, so what's plus this measure and plus this measure? Be 2X plus 16. And because we are multiplying these, I put them in parentheses, and now I have two binomials. So, an equation that can be used to find X, the width. So we are almost there. I'm going to add one little change here. So we have an A, an unknown, and an X. We can't have both. So it does tell me up here that the area is 396. So my final answer for this first one is 396 equals 2X plus 12 times 2X plus 6. And that's my equation. Describe how your equation models the situation. So, alright, so I said the area of a rectangle is found by multiplying the base and the height. I found the new base by adding the base of the garden and the width of the walkway on both sides. That's the 2X. I found the height by adding the garden height and the width of the walkway on both sides. Again, that's the 2X. I then set the area equal to the given new area so that I could solve for the missing walkway's dimensions. So I spelled area wrong on there, but I know you're okay with it. Alright, so then the last question says, determine and state the width of the walkway in meters. So now I'm going to go ahead and solve it. So 396 equals 2X plus 12 times 2X plus 16. So that should be a 16 right there. Aha. Thought I'd skip that step. Should be a 16 there too. Alright. So to solve this, I'm going to think through all my steps of math. I'm solving an equation, so 396, I can't do anything with that. On the other side, I have a FOIL problem. So I get 396 equals, so this is a FOIL, first, outer, inner, last. So 4x squared plus 32x plus 24x plus 32. Oh, sorry, plus 192. And combine like terms. 396 equals 4x squared plus 56x plus 192. Again, I'm going to try to put this into standard form. So I'm going to make this all equal 0, so I'm going to move 396. So 0 equals 4x squared plus 56x minus 204. Okay, so now I'm going to try to factor this in some way. So always GCF. So I'm going to try that first. So 0 equals, try to divide everything by 4. I get x squared plus 14x minus 51. So because I have two factors here, one of them has to be 0 or both. So that 4 is equal 0 doesn't make sense, but it's still out front. So let's see 0 equals 4, and let's see if we can double bubble this. Two things that multiply to 51, add to 14, well, positive 17 times negative 3, add to 14 and multiply to negative 51. So I need to find the roots here. I can get 0 equals 4, not possible. X plus 17 equals 0. So x equals negative 17. We can't have a distance of a walkway that's a negative number. Not possible. And then the last one, x minus 3 equals 0. So x equals 3. That's a positive dimension that we can have. So we're looking to determine and state the width of the walkway in meters. 3 meters. That's the width of the walkway. So we could put is the walkway width. And we're finished. That is a great Regents level problem. And it would be worth see 2 points, I believe. Yeah, this is going to be worth 2 points in the Regents exam. So it is a lot of work, but again, it's a lot of practice from all of our math practice we've had. Alright, so that finishes our notes. Again, if you haven't gone back and finished those ones you skipped, go back and finish those. Rewatch some things if you need to. Go back and visit your notes from old units, whatever you need to. Good luck.